Hello everyone, good evening. So how are you all doing? Yes. Hi Gautam. We have Raj Nandini here. Good evening Nandini. Hello Gautam. Hi Himanshi. Harshita, Paramveer. Hello. Hi Aditi. Yes. Amrita, Nibha Chaudhary, Sahitya. Yes, a very good evening to all of you. My name is Khushbu and a very warm welcome to yet another wonderful session. Yes, so what are we going to learn today? Yes, new in the class. I'm sure you will love this session, Harshita. Hi Abhiditya, I can see some new names over here. Hi Balwant Singh, Shruti, Astha, Harsh Suryavanshi, Sunny, Shruti Deshmukh. Yes, hello everyone. Yay, math class. Wow, this sounds interesting. Somebody likes maths because we never find students who actually like maths. Generally, students have this thing like they have a hatred for maths. I don't know why. Though it's a very easy subject. Thank you, Harshita. I'm glad that you're actually liking it. Yes. Harshita, love maths. Yeah, great. Good to hear that. Well, I'm excited too, Nibha. Yes, hi Ranjana, hello Jyoti. Yes, Nakul, Tejaswini. Confused in math. The math is an easy subject. Why do you get confused in it? See, if you understand the concepts well, it's all about understanding, right? All right. So, what are we going to learn today? So, basically this session is about, it's a bridge session and followed by a quiz. We will be learning real numbers, right? So, let me first quickly discuss the flow of this session with you, like what all we are going to discuss today. So, first we will talk about why we actually need a bridge session, right? Because we have come up with this. Then we will talk about real numbers, irrational numbers, operations on rational and irrational numbers, laws of exponents, and then what we will be learning next in the new grade, right? So before we start the session, quickly subscribe the channel if you haven't yet so that you do not miss any new updates from us, so that you get notified about the upcoming sessions, right? Yes, new batch, right? That's our BYJU'S achievers. Yes. Maths is favorite. Wow, glad to hear that. That's amazing, Neeti. No, not Menti, but yes, we will be having a quiz. Alright, so let's get started. But before that, I want you to meet someone. So this is Abel, and just like you, Abel has also got promoted to grade 10, and he is also very excited that now we will be learning the new concepts. Wow, new books, new class, new concepts, right? It happens with everyone. I remember my time when I was in grade 10, I used to be very excited. Wow, we have come to a new class. Everything is going to be new. Right, this thing remains for a few days, for a few weeks, and after that, you know, all the enthusiasm, we lose everything, right? Whatever, initially we are full of power, full of enthusiasm, and then we become lazy, we become lethargic, we don't feel like studying after that, right? Maths is not tough. No, it's not that I'm your math teacher, that's why I'm saying it. Honestly, it is not tough. It's all about understanding. Moreover, if you are regularly attending the classes, you would see a difference. Gradually, you would see that you are actually improving. Wow, amazing, Amrita. All right. So, Abel is just like you. He's also very curious to learn the new concepts, right? But before we jump off to the new concepts, right, what we need to do is we are going to do a quick recall of what we learned in the previous grade. So, that's why we have come up with a bridge session. So, in grade 9th, you learned about number system, right? That was your first chapter. Now, in grade 10th, we are learning real numbers. Now, both these two chapters are linked to each other. So, in grade 9th, we learned about rational numbers, irrational numbers, rational numbers and their decimal expansions. So, all these things will be used in grade 10 also, all these concepts. Apart from that, we will be learning two more new concepts, that is Euclid's division lemma and fundamental theorem of arithmetic. Can you see there is a connection between the grades, right? So that's why, like let's say if these topics, you did not understand these three topics well in your previous grade, so definitely you are going to find it difficult when you start learning the concepts in grade 10, right? So I think I'm answering to your question that why you find math stuff, maybe your concepts, your fundamentals are not clear. So first we are going to do a quick recall of the topics that we have studied in the previous grade, right, in number system. Thank you, Aditi. Right, Akansha. Agree. Thank you, Yashika. All right, all right. So let's get started. Now Abel is also very excited. So he has also understood that we should first recall what we have learned in our previous grade, right? Just to strengthen our fundamentals on that previous topic. So since this topic is about real numbers and the previous grade that we learned about number system, right? So when I'm talking about their linking, we have seen a lot of numbers, right? A lot of different types of numbers. So now what we are going to do is we are just going to categorize them first, right? Just a quick recall. So we have learnt about numbers, we have learnt about natural numbers. Natural numbers starts from 1 and extends up to infinity, 1, 2, 3 and so on. We have learnt about whole numbers also, right? So if I add 0 to this list of natural numbers, it becomes whole numbers. So whole numbers starts from 0 and extends up to infinity, 0, 1, 2, 3, 4, 5, right? See why we are explaining all this, so that you have a concept clarity in your mind, right? All right. And if I add negative numbers over here like -2, -1, -15 something, then it becomes integers. So integers include the negative numbers 0 as well as the positive ones, right? But no decimal numbers. Many times students ask me this thing, do integers are also including decimal numbers now? No. We have -2, -3, -4, 0, 1, 2, 3, so on. No decimal numbers, no fractions here. Yes? Wow. Thank you, Rishit, for such great words. Yes. All right, and talking about these -3, 1 by 3, -3 by 4. So these are rational numbers. So what is this? This pi and √2. These are irrational numbers. Now can you see this has been shown separately, right? So I can say one thing, that whole numbers includes natural numbers also. Integers includes whole numbers as well as natural numbers. Rational numbers include all of them. But irrational numbers are not a part of it. It is written separately. But real numbers include all of them. Whether it is rational, it is irrational, integer, whole number, natural number. I hope this is clear to everyone, right? All right. So irrational numbers, we have shown here pi and √2, right? So now if I try to represent this in the decimal form, it's written as 3.1415 so on. And here 1.4142 and so on. So what is the difference here in these numbers and these numbers? What is the difference between these numbers? Because I can see different types of decimal numbers over here. So let's first take a look at what all kinds of decimal numbers do we have. So what are the different types of decimal numbers? Raghavan, combination of rational, irrational. Yes, if we combine rational numbers and irrational numbers, we get the real numbers. So on the real number line, we have everything. Yes. That's what, decimal and diagram, that's what I'm trying to explain you. Yes. So, what are different types of rational numbers? Different kinds of numbers I can see here. So, first let's categorize them. If I try to categorize these numbers, I can see in the first category, you see here it is 2.76 and this is 1.25, right? This numbers ends here. These are not repeating. So, these have a terminating decimal expansion. Terminating means it ends there, it terminates there. Yes, this is right, this is terminating. Thank you, neat aspirant. I'm so glad. Oh, your name is Deeksha. Wow. Yes, so this has a terminating decimal expansion. Talking about 1.33, 1.272727. What I can see here is that it is not ending, it is not terminating, but it is repeating itself after the decimal point. So it has a non-terminating but repeating decimal expansion, right? So this is something you have already learned. We are just doing a quick recall, right? Then we have 1.4152 and so on, 4.7235. What I can see here after the decimal point, it is not ending, it is not terminating and it is not repeating also. So this has a non-terminating and this is neither terminating nor repeating, right? All right. Understanding clearly? Yes? That's good. Alright, so this is clear to everyone, the different kinds of decimal expansions we have see here. Now, how do I figure out which is rational and which is irrational among them? So, what is the difference between rational and irrational numbers actually? Yes, let's check that. So, if I take a look at these numbers, 1.25 and 0.141414, you see this has a terminating decimal expansion. If I talk about this is not terminating, this is not ending, but these numbers are repeating after the decimal point, 1, 4, 1, 4, 1, 4. This is non-terminating but repeating decimal expansion. These kind of numbers which have a terminating decimal expansion or non-terminating but repeating decimal expansion, we call them rational numbers. Thank you, Art Monster. Wow, such an interesting name. Yes. So I hope this is clear to everyone, how to categorize, how to find out rational numbers and irrational numbers. You have done it before, but let's just quickly recall it because all these concepts are going to be used in our new chapter, real numbers. So we need to strengthen these concepts first. Yes? We need to have a good command over these topics. Yes. Terminating, non-terminating, repeating. Yes, they are rational. All right, this is clear to everyone. Great. Talking about the irrational ones. So look at this number, 1.414213. This is not terminating. This is not ending, but the numbers, the digits after the decimal point, they are not repeating itself, right? And look at this, 4.123105, so on. Here also, so both of these have non-terminating but non-repeating decimal expansion. We call them irrational numbers. But all of these, they come under real numbers. Yes? So I hope this concept is clear to everyone now. Right? Yes, 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 Deepak. This is for 10th standard, right? Clear, Raghavan? Yes? Quickly give me thumbs up and smileys in the comment section so that I can understand you all have understood this well. No confusion is there. Astha, yes ma'am. Manoj, yes. Yashika, yes ma'am. Pehel, non-terminating, non-recurring, yes. Raghavan is giving thumbs up. All right. Thank you, Sahitya. Clear, Astha, Abhiditya. All right, all right. Thank you, Umar Anis. So I can see thumbs up and smileys in the comment section. Wow. Amazing. So this is clear to everyone, right? Now if you remember, just a couple of minutes before I said pi. Pi was written in the category of irrational numbers. So we know that pi is an irrational number. We have been learning this thing in our books. But have you ever wondered why we call pi an irrational number? Why is it called an irrational number? Yes? Well, let's take a look at this. Because pi, can you see here? Just look here. Look at these numbers which are written in blue. These numbers are never ending, right? Right? They are non-terminating and numbers are not even repeating itself. So pi is called an irrational number because it has a non-terminating, non-recurring decimal expansion. Yes? That's why we call it an irrational number. So we all knew that it is irrational, but now we know the reason as well, why it is called irrational. Anonymous, 0.9029, 9029, 2009, 2000 rational. That's absolutely irrational because you see after the decimal point, digits are not repeating themselves, right? Different digits are coming. So that's basically irrational. Yes, Doha Corner. Integers are also real numbers. So let me make one thing clear. So you will have a clear thing in your mind. When I'm saying real numbers, right? So real numbers has everything, right? It has irrational numbers also, right? It has rational numbers also. And rational numbers have everything, right? Rational numbers have got what? In rational numbers, we have got integers also, we have got whole numbers also, we have got natural numbers as well, right? So real numbers include everything. Irrational, rational, integers, whole numbers, natural numbers. Missing Menti a lot? Don't worry. We have a quiz right after we finish all our concepts. Yes? So in quiz also you have a timer. It's more like Menti only, right? Yes. How we get pi 3.14? ऐसा divide करो ये आता है. ऐसे. Sorry, I'm not able to understand your question. ऐसे divide करो ये आता है. Yes, we also write pi as 22/7, right? Because see, this value we generally, this is obviously an approximate value, 3.14 something, we are using in approximation. So in the questions we generally use pi as 22/7. But if it is mentioned in the question that you have to use 3.14, then you will be using 3.14 only. So obviously in grade 9th you had surface areas in volume. So you would have used this value very frequently, right? So you know that where to use pi as 22/7, where to use 3.14. Yes. Right. So in the decimal expansion, that's 3.14 something. But in fractional form, we use it like this. Oh, Menti has its own feeling. Oh my God. Oh, I can understand that. Yes. Timetable for the new academic year. I think we have done a session on that. It's there on YouTube. You can watch the recorded session. We have discussed like what should be the timetable, what should be the strategy for the new academic year. Yes. All right, all right. So this was about the rational and irrational numbers, right? Now let's try out some questions. Let's see how much you have understood. So here we go. Among the given numbers, dash is an irrational number. You can see 4 options on the screen. You have to find out the right answer. I'm giving you 30 seconds for this and I'm starting the timer now. Quickly, tell me the answer. Yes. Yes. Oh, you guys are so fast. Nirmali says it's B. Rishit Solanki says it's B, that's root 2. Jyotsna, Yashika, Amrita, Nirmali, Nisha Chaudhary, Paramveer, root 2. Everyone is saying root 2. No one has a confusion as this. That means this topic is very well understood. Yes? Alright, time is up. Let's check the answer. Yes, absolutely, it's option B. So among the given numbers, root 2 is an irrational number. So we all know it, right? Now let's take a look at another question. Let's move ahead. So circle has a radius of 7 centimeter. What is the nature of its circumference? So 4 options you can see on the screen. Quickly tell me. When I'm saying nature, so first we will find out the circumference, then only we'll be able to tell whether it's irrational, rational, integer or a whole number. Okay, are you giving me the answers for this question? Yes? Tarushi, Harshita, Parvati. Okay. Alright, let's see that. So circle has a radius of 7 centimeter when we are saying, right? So the nature of its circumference. So first we will have to find out the circumference, right? So how to find this out? Circumference is 2 pi r, right? What is the radius here? Radius is 7 centimeter. Put it here, you get 14 pi, right? 14 pi. So the value of circumference is 14 pi for a circle, that's 7 centimeter, right? So that means I can say that this is going to be irrational in that case, right? Is that would be the answer? Quickly tell me. Yes. 14 pi, we are getting the value of the circumference, that's 14 pi. So 14 pi, if you see, what will I say? 14 pi, but if I put the value over here, that's 22 by 7, and you cancel this out, you get 44, right? Right? So what will be the answer? Is it going to be rational or is it going to be irrational? Yes. Radius over here, 7 centimeter, 14 pi. Quickly. Yes. Why can't we take 22 by 7 as pi? We can put that. We can do that. So 44 centimeter would be the answer. That means option B. It would be we can call it a rational number or whole number or integer. Because it comes under this category, we will call it a rational number. Right. We will call it rational because if I don't put pi, because if I substitute it, then I am going to get this value, right? So what do we put here? What do you think? I'll call it rational, irrational. That's confusing, right? So here what we are going to do is, because as I said, pi is an irrational number, right? Pi is an irrational number. What did I tell you? Since it is an irrational number, that means 14 pi. Anyways, if you are multiplying a rational with a irrational, you would get the irrational only, right? So it will be irrational, yes, not whole number. Because we don't know, it's not necessary that you would put 22 by 7 only. 3.14 could also be put, right? And that is an approximate value. We know that it's never ending number. Right, so that's irrational. I hope this is clear to everyone now. We just discussed pi is an irrational number. So when you are multiplying a rational with a irrational, you will get an irrational number only. Right? This is, you have learnt in the previous grade. Though we will do a quick recall on this concept as well today. This is clear? Yes? Alright, great. Alright, so let's move on. Let's see what do we have next. So operations on rational and irrational numbers, right? So now we are discussing this concept only. So addition or subtraction, right, of a rational and irrational number will always give us an irrational number. Let's take an example. Like we have 2 plus 2 root 5, right, or 2 minus 2 root 5. Again, always we will be getting the irrational number only. Yes? Nirmali. Yes, it is not necessary. That's why I said pi is irrational. That's why we are considering it as irrational. So these kind of things, these kind of questions might confuse you in the exams, right? So you can't just put 22 by 7 or 3.14 straight away. No. Yes. All right. Okay. So these concepts that you are seeing here, this is important. Talking about the next thing, rational. The same thing that we just discussed, multiplication of a rational and irrational number always gives us an irrational number, like 14 pi, right, irrational. So 3 times root 2 will give us 3 root 2. Ma'am, what do we say this sign plus minus? Nothing, plus minus. We say it like this only, plus minus. So instead of writing 2 plus 2 root 5 and then 2 minus 2 root 5, just to save time, we write it this way. It's plus minus only. Yes. Iota, you will learn that in grade 11th. Focus on grade 10th right now. Though iota, that we denote it by square root of minus 1. But it's not a part of grade 10 though. So let's not talk about that. Let's not discuss that. Okay. All right. All right. So that's going to be 3 root 2. All right. This was just an example. So division of a rational and irrational number always gives us irrational number. Like 4 divided by root 2 will give us 2 root 2. Right? Yes. Normally, I am not able to understand your question. I am not always take the rational number as 0. 0 is also considered as a rational number. Yes. 33 root 3 plus 11 root 3. That's going to be 44 root 3. Divya. Yes. Yes. Correct, Tarushi. Yes. It can be, it would be positive or negative. All right, all right. All right. So these are the examples that we have used here, right? Coming to the next thing, addition or subtraction of two irrational numbers. The answer could be rational or irrational. So 2 root 7 plus root 7, we have 3 root 7, right? So we are getting an irrational number, right? So answer could be rational also. Can you give me one example where we can get a rational number from two irrational numbers quickly? Yes, Arjun. What doubt you have? See, whatever doubt you have, you can just write in the comment section. Yes. Any example where we get a rational number from two irrational numbers? Yes. Root 2, I'm not talking about multiplication. Here we are talking about addition and subtraction. Okay, let me give you an example. Let's say one number is 2 plus root 3, right? Another number is 2 minus root 3. We have these two numbers. I'm adding them up, right? So root 3 gets cancelled out. We have 4. You get a rational number, right? So that's why I'm saying addition and subtraction of two irrational numbers, it can give you a rational or an irrational number. Depends. Deepak, you're using the same numbers. That is also fine. It works. But yes, if in case we use different numbers, so anonymous, no, that's absolutely wrong. I have seen a lot of students doing that. Root 2 plus root 2 cannot be root 4. It will be 2 root 2. So how do we add root numbers? See, root 2 is written. What is written outside this? Nothing is written, we have 1. Nothing is written, we have 1. So the digits that are written outside, they are added up. You get 2. Root 2 remains as it is. Right? Let's say I have got 2 root 2. I have got 5 root 2. I have to add them up. So root 2 will remain as it is. And this 2 and 5 will add up. They give you 7 root 2. That's how we add it. Yes, Arush. So 0 is a rational number. But here I took different numbers, different irrational numbers. That's also fine. Rationalization, why do you have to rationalize it here? Nibha, I'll come to this point where we actually use rationalization. Here there is no need to use rationalization. Yes. Anonymous. Okay, you understand your mistake. Okay. Yes, root 2 minus root 2, you get 0. It is rational. Yes. But you are using the same numbers. That's why what I'm saying. If I use different numbers, different irrational numbers, then also we can get a rational number. Yes, Hemlata, that's fine. Amrita. Yes, depends on the condition, right, Akansha, right. So what you have. So what I'm trying to say here is addition and subtraction of two irrational numbers can give you rational or an irrational number. It depends, right? Root 3 minus 2 root 3. So what do you get? Root 3 minus 2 root 3. Root 3 remains as it is, right? Here we have 1, here we have minus 2. 1 minus 2 will give you minus 1. So we have minus root 3. Yes? So Nisha, I think you're asking about the previous thing. 4 by root 2. How to solve this? So 4 could be written as 2 times 2 and we have root 2 in the denominator. I can split this 2 as root 2 times root 2 by 2 like this. This will get cancelled. We have 2 root 2 at the end. Right? No confusion still here. I hope till this part, this is clear to everyone. Quickly give me thumbs up, smileys, hearts in the comment section so that I can understand this is very well understood. Yes? Sonali Day, got it. Nirmali, okay. Nisha, yes ma'am. Quickly, yes. Okay, you're Bishal, alright. Astha, yes. Alright. So this is clear to everyone. Lots of smileys and thumbs up, hearts I can see. Wow, amazing. Let's move ahead. Let's take a look at the next one. So multiplication of two irrational numbers, right? It can give you a rational or an irrational number. Again, it depends. Let's take an example. We have 5 root 3 times root 3. So how do we multiply that? Root 3 becomes 3, right? 5 times 3 is going to be 15. We have a rational number, right? Let's say, let me give you one more example. I'm just rubbing this off. Let me give you one more example that when we can get an irrational number. Let's say I have root 3, I have root 2. So this becomes what? Root 6. I'm getting an irrational number. So it depends on the condition. We can get a rational or an irrational number, right? Clear, everyone? No confusion still here? Yes? 8 root 5, 27 root 5. So this will give you a rational number, Raghavan, because root 5 will become 5. 5 times 8 times 27 will give you a rational number at the end. Yes. Correct, Deepak. Alright. This is clear to everyone. Great. Let's take a look at the next one. So irrational number and irrational number. That means if we are dividing two irrational numbers, we can get a rational or an irrational number. Like here, 4 root 2 divided by 2, you get 4, right? And let's say you take any other example, you might get an irrational number also. Yes? I hope no confusion still here. This is clear to everyone. Yes? Alright, great. So we are done with this. We have done a quick recall of this concept. Now let's try out a question on this. So which type of number will be obtained on the multiplication of root 8 and 3? Quickly, we will get an irrational number or a rational number. Quickly, give your answer in the comment section. Yes. Hasta, clear. 5 root 3, 5 root 2. That would be 25 root 6, Hemlata. So 25 root 6 is irrational number. Yes. Everyone is saying A, irrational. Doha, Nisha, Raghavan, Bishal, Nirmali, Sahitya. Yes, absolutely. It's going to be an irrational number. Multiplication of a rational and irrational, we get an irrational number. So no confusion still here. Now coming up next is a poll question for you that you need to answer all by yourself. Let's take a look. How many rational numbers lie between two rational numbers? So you can see 4 options over here and you will get 30 seconds to answer this question. I'm starting the timer now. Yes. Alright, quickly, is it for this question? Everyone is saying C. Abhiditya, Yashika, Deepak, Varshini, Diksha, Nirmali. Everyone is saying C. So you are sure of it. Yashika, Infinite. Pragyanzu, Jagdish, C. Okay. Everyone is saying C. Okay, time is up. You're right. It's option C only. Because we have seen that on a number line, between any two rational numbers, there can be infinite rational numbers. Right? Yes. Alright, cool. Let's move ahead. Let's take a look at the next question. So, rationalizing root 2 plus root 3 upon root 3 minus root 2 will give. So, you all have done rationalization in your previous grade. You have learned that. Quickly rationalize it and tell me what the answer is going to be. So, somebody was asking me, I remember the question, to check whether it is rational or irrational. You were saying rationalize it. There is no point, even if you rationalize it, still you will get, like let's say the answer was irrational, so you will get the irrational number only. So, we rationalize it when we have the roots in the denominator, or sometimes when it is there in the numerator, still we do the rationalization. Depends on the question. Yes? You must have done such kind of questions in your previous grade. Yes, Sunny, you're right. Class mein sab padhne wale bacche hain. I can see that. Alright, so let's do rationalization. You are saying C is the option. Okay, let's check that. So we have got root 2 plus root 3 upon root 3 minus root 2. How do we rationalize it? Whatever sign we have in the denominator, we just change that sign, right? So we will multiply the numerator and denominator by root 3 plus root 2. So numerator, you can see it is same, right? So we can say it is root 2 plus root 3 whole square. In the denominator, we have the identity a minus b, a plus b. That's going to be a square minus b square, right? Which is Root 3 square minus root 2 square, that's 3 minus 2. We will open the identity in the numerator. So a square plus b square plus 2ab is 2 plus 3 plus 2 root 6. In the denominator it is 1, so no need to write that. So 5 plus 2 root 6. That means it's basically option B, 5 plus 2 root 6. Absolutely, you all are right. Arush, Sahitya, Amrita, Abhiditya. Right, B is the right answer. Wow, so that was easy, right? So Abel is also very excited. Now let's move ahead. Let's take a look at the next concept. So we have also learnt about the law of exponents in the previous grade, right? Let's quickly do a recall. So when the bases are same and powers are different, what do? We simply write the base as it is and we add up the powers, right? And when it is written in the form a to the power m whole bracket n, we simply multiply the powers, right? And if we get this in the division, bases are same and powers are different, we simply subtract the power. So it is a to the power m minus n, right? And a to the power m times b to the power m. Now powers are same but bases are different. What do? We multiply the bases and keep one power for both of them. So ab to the power m, right? Then a to the power 0, anything raised to power 0 is 1, we know that. So this is the law of exponent. It is very frequently used in the questions, right? Yes, this is clear to everyone. Now let's try out a question so to check that whether you have understood this or not. So match the following using the laws of exponents. Here you can see we have got in this column 3 cube and this thing and this, and on the right side we have got a few numbers. You have to match them with the correct one. So 3 cube, what would be the answer for this one? Yes. Yes, 3 cube. 3 cube is nothing but that's basically 3 times 3 times 3. That's going to be what? Absolutely right, Yashika. That's 27. Can you tell me 3 to the power 3 by 2 by 3, what is this going to be? Yes. So 3 to the power 3 by 2 and here we have got 3. So this has got a power 1. So bases are same. We just revise the laws of exponents. In that case, we subtract the powers, right? So that's going to be 3 to the power 3 by 2 minus 2, which is 3 to the power 1 by 3. This 1 by 3 is nothing but that's actually root 3. Right, absolutely. Nirmali, Raghavan, Gautam, yes. And 3 to the power 0 into 1 by 2. So what do? We multiply the powers. That's going to be 3 to the power 0. Something raised to power 0 is 1. You all are right. So we all have understood, right? All right. So this was about the laws of exponents. So that was the quick recall of what we learned in the previous grade, right? So I think we have strengthened our fundamentals on the previous concepts and we will be using these concepts in grade 10th now. So what is coming up? So in our new grade, what are we going to learn? Because our very first chapter is real numbers, right? So in real numbers, you will be learning about Euclid's division lemma, fundamental theorem of arithmetic, revisiting irrational numbers and revisiting rational numbers and their decimal expansion, right? So all these concepts will be used here, yes? So before learning any concept, this is the way. First, we should strengthen what we have learned before so that we do not face any issues while learning the new concept, right? Our journey becomes very smooth, yes? All right, so we are done with all the topics, like the topics that we had in the grade 9th and what we are going to learn. Now it's quiz time, yes. So let's start with this. Are you all ready? Yes? All right, let's get started. So here is the first question. The value of the area of an equilateral triangle is irrational. What can you say about the sides of the triangle? So you will get 30 seconds to answer this question. I'm starting the timer now. Yes. Harshita, which one? The laws of exponents, yes? So that's very simple. So when bases are same, we simply add up the powers. When bases are different and powers are same, we multiply the bases, right? And keep the power as it is. So only those laws of exponents we have used here. And very simple calculation was there in the questions. All right, so time is up. So everyone is saying C. Kunjal, Arjun, Hemlata, Amrita, Doha, Nisha, Sahitya. Everyone is saying C. Let's check the answer. Yes, you're right. It can be rational or irrational. So I hope this is clear to everyone. Yes. Raghavan says B. How come, Raghavan, you are saying B? Because you see area of an equilateral triangle is root 3 by 4 into side square. So let's say first time my side is rational number. Rational number, let's say it is 2. So it is going to be root 3 by 4 into 4. I am getting a irrational result, right? So area is irrational. What if my side is rational? Let's say this time it is root 2. It's going to be root 2 square. So root 3 by 4, that's going to be 2. I'm getting root 3 by 2. Still I'm getting an irrational number. Let me write this down here. I'm getting root 3 by 2. Still I'm getting an irrational number. So it doesn't matter whether my side is rational or irrational. Every time I'm getting the result as an irrational number. Yes? I hope this is clear to everyone. Yes? No doubt still here. Okay, you read the question now. Alright. Alright, let's move ahead. Let's take a look at the next question now. An irrational number between 1.01124 and 1.01242 is. Quickly look for the right answer. I'm starting the timer now. Yes, clear to everyone. Great. This is simple. We just have to look for an irrational number between two numbers. Yes. Samrat says it's A. Okay. Astha says B. Harshit says C. Okay, mixed answers. Some are saying A, some are saying B. And C also I can see. Okay, so basically we have a confusion here. But mostly students are in favor of B. Pranal, Raghavan, Deepak, Nirmali, Hemlata. Okay, time is up. Let's check the answer. Yes, it's B. So let me just explain it to you. See, in these numbers, what do we have here? We can see here it's the digit before the decimal point, it's 1. This is same. So let's move ahead. This is 0, this is same. Then we have 1 here, then we have 1 here and 2 here, right? So this is basically 1, 2 and this is basically over here 2, 4, right? So till here the digits are same. Now I'll check between 1, 2 and 2, 4. So if I check this digit between 12 and 24, so this is same till here, this is same till here, this is same till here, this is same till here. This is the way to check it. So here we have got 0, 2. Obviously between 12 and 24, 0, 2 will not come. This cannot be our answer. We are eliminating the options which can't be the answer, right? And then option B, we have 12, right? So it starts from 12 to 24. Between 12 to 24, it is 1 to 4, it is 2, 4, 2. Obviously 1, 2, 6 will definitely lie between this. This is our answer. Let's check option C also. This is 1, 5, 6, right? So this is 1, 5, 6, it is 1, 2 and this is 2, 4, obviously. So here, this number, this will not lie between this, right? Similarly for this one also. Any confusion still here? Yes, bridge sessions are important. They actually help you in strengthening your concepts. Yes. Any doubts still here? Varshini? Yes. Why can't option C? So here we can see that we have got 1.01, 1.01, right? It is 1, 2 and it is 2, 4, right? So between 1, 2 and between 2, 4, 1.01, 1, 5. Yes, this could also be included, right? You are right. Yes. So basically for this question we can have two options, right? So if I look here 1.01 and this is 1, 2 and this is 2, 4. This could also be included in this. Yes, you're right. C or D, and looking for this option 1.01 and this is 2, 5. See, this is 2, 5. This can't be included. It will exceed this. This is 2, 4. So 2, 5 can't be here. But between B and C, they both could be the answer for this question, right? Yes. Now, but when we are saying, yes, good point you have said, we are talking about an irrational number. This has a terminating decimal expansion, so this cannot be our answer. Yes, this can't be our answer. This has a terminating decimal expansion and this is 25. So 25 is anyways not included here. So we can go with option B only. Yes, Harshita, Astha, chamak gaya, right? This has a terminating decimal expansion. Terminating, when I say, there only rational numbers have a terminating decimal expansion. Question is asking for irrational number. We cannot take that. And 25. So 25 will come after 24. You cannot take that, right? That's okay, Harshit. That's okay. All right. So this is clear to everyone, right? This option B. No, Harshita, you cannot take C because that's terminating, right? I hope this is clear to everyone. Yes. Thank you, Astha. How to know whether the fraction is terminating or non-terminating repeating? Just by looking at the decimal expansion. See, there is nothing written after 6. No dot 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 is there. So this has a terminating decimal expansion. So that is a rational number, right? Now this also has a terminating decimal expansion. We cannot include this also, right? So there was no point of looking for it, right? This also has a terminating decimal expansion. I did not notice the dots. Here both of them have got dots. Now we can see that numbers are not repeating. They are different, right? So when numbers are different, they are not repeating. That means it has a non-terminating and not repeating decimal expansion. So just by looking at the number, you can say that. Yes? All right, all right. Let's move ahead. Let's take a look at the next question. Which of these numbers lie between 5 and 6? Quickly, I'm giving you 30 seconds to answer this question. I'm starting the timer. Yes. This lecture is for grade 10. But yes, it's a bridge session. We are recalling the topic, so you can also attend it. No, sir, it's absolutely not. Yes. Hema says 25. You mean option A? Okay. Squared here is square root. Please, this is square root. Square root 25, square root 20. Yes. Thank you, Ashita. Yes. Raghavan says root 30. Oh, yes, option D is the right answer for this question. All right, all right. Some are saying C, some are saying D. Okay, between 5 and 6. So between 5 and 6, we know a lot of numbers would be there. Square root of 5. Square root of 25 is 5. So this cannot be our answer. We are looking for a numbers which lie between them. Between, right? Square root of 20. Square root of 20 would be 4 point something, right? So 4 point something would be before 5. So this cannot be our answer. Square root of 40 would be 6 point something. It will come after 6. This can't be the answer. Square root of 30. Obviously this is 5 point something. So option D is the right answer. Yes? Clear to everyone? Yes, Tanish, Harshita, Arjun. All right. I gave you the answer. Why not A? Because square root of 25 is 5. So question is saying numbers lie between 5 and 6. You cannot include 5 and 6. In between that. Okay? Yes? No confusion still here? Thank you, Arshita. Clear. Great. Let's move ahead. Let's take a look at the next question. If A is 5 upon 1 plus root 3, then find the value of A plus 1 by A. 30 seconds you have to answer this. Let's start the timer. Yes. Yes, National Talent Search Exam. We talked about this in our session also. Yes. How to start your new academic year strong. You can watch that. I've talked about it, like what is the eligibility criteria, how many times it happens, the duration, all everything. Yes. Thank you, Varshini. All right, time is up. So what is the right answer? It's D. Gautam says it's B. All right, let's check how to, because D is the right answer. Let's check the solution. So this is A, right? So first of all, A plus 1 by A. A is 5 upon 1 plus root 3. 1 by A is going to be reciprocal of it. So I'll take the reciprocal. So what is the reciprocal over here? I am simply writing this as root 3 plus 1 by 5. Same thing, right? 1 plus root 3 plus 1. Same thing. But it becomes a little easier when we write this way. Yes? All right. Now I'll take the LCM. So we have 5 times root 3 plus 1. So 5 times 5 would be 25. And here it becomes root 3 plus 1 whole square. Right? Yes? All right. So here we have got 25. How to open whole square? A square plus B square plus 2AB. So 3 plus 1 plus 2 root 3. And this is 5 times root 3 plus 1. Right? So this is going to be what? This is going to be 29 plus 2 root 3 by 5 times root 3 plus 1. This doesn't match with any of the result. Right? So I'll have to rationalize it. So let's rationalize it. What do we get? Alright, so 29 plus 2 root 3, right? We have 5 times root 3 plus 1. I'll multiply this by root 3 minus 1 and here also by root 3 minus 1. So what do we get here? Let me change the color. So we have 29 root 3 minus 29 plus 6 minus 2 root 3 and this is 5 times root 3 plus 1, root 3 minus 1. Identity is here, a square minus b square. That's 3 minus 1, which is 2. So I'm writing here, this is going to be 29 root 3 minus 2 root 3, that's 27 root 3. Minus 29 plus 6, that's minus 23. 5 times 2 is 10. That's why option D is the answer. Wow, that's amazing. That's amazing, Sarita. All right, I hope this is clear to everyone, right? How we are getting this answer. Yes. All right, all right. Let's move ahead. Let's take a look at the next question. Which is greater, 2 cube or 3 square? Quickly, 30 seconds you have. You know that you have to answer this question in 30 seconds. Quickly, tell me which is greater. This is a very simple one. Yes? All right, all right. Everyone is saying it's A. So this was a simple one to answer, I know. So Shruti, I have discussed all that in that session, how to start your new academic year strong. We have talked about NCERT. You can watch that section of that session. All right, so some are saying B also. Well, it's A. Yes. All right, A is the answer. Which is greater? 2 cube is 8 and 3 square would be 9. So obviously 9 is greater. So 3 square is greater. A is the right answer. So this was the last question of today's quiz, but that's not all because we have got homework for you as well. So the question is, if root 2 is irrational number, show that 2 plus root 2 is an irrational number, right? You can solve this question after the session gets over and you can let us know your answers in the comment section below, all right? All right, so don't worry, we have got you covered. We have lined up many more sessions for you from every Monday to Friday to make you exam ready. So many things we will be covering. So let me give you a glimpse of the upcoming session. So our next session is on 21st April, that is Thursday at 6 p.m. And that is going to be our first concept session, yes, on real numbers, right? So we'll be learning the new concepts that we have in real numbers, right? All right, so do not miss the session because we have done a quick recall of what we learned in the number system in the previous grades, right? So all those small things, those concepts will be used here as well. So what you can do is you can also do a little bit of practice on all the concepts, right? Just 2, 2, 3, 3 questions on all the concepts of grade 9. All right, all right. So, and we have got free trial classes as well. So link for that is given in the description below. So click on that link and get all your doubts clarified instantly during the class. And please like, share and subscribe so that you do not miss any new updates from us. Yes. All right, all right. So I'll see you soon. Till then, keep learning, keep exploring. Thank you. Bye-bye.